Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, we'll have a quick review on permutations and combinations, and I'll be giving you some basic definitions of these two concepts along with some examples. So let's start by looking into the differences between permutations and combinations first. Permutations are based on arrangements of things, whereas combinations are based on selection of things. So these are the two code words to identify whether the question is under permutations or under combinations. So if you have arranging things, then it comes under permutation. If you are selecting things, it comes under combinations. Now look at the notation NPR. The P stands for permutation and NPR stands for R permutation out of n objects, which means if you have n objects and you have to arrange R objects out of these n objects, we say that this is an R permutation of n objects. Whereas combinations are written as NCR, which means R combinations of n objects, which means if you have n objects and you have to select R objects out of these n objects, then we use combination and the notation is NCR. There are also other notations for these two, NPR and NCR. In some books, you can see that it is written like NPR like this, or in other books, you can see the notation like this or like this. All these refer to permutation NPR. Whereas for NCR, you have different notations as well, NCR like this, or NCR like this, or CNR like this. Or there is another extra notation for combinations, which is written like a column matrix, NR within the brackets like this. So all these notations represent combinations and all the P notations represents permutations. So let's look into some examples how to find permutations. Say for example you have 8P3. So how to find 8P3? You have to start with 8, multiply 8 by 7 and then by 6 and stop there. Since this is 8P3, you need to have 3 numbers starting from 8 reducing by 1. So start from 8 times reduce 1 7 times reduce 1 6 and you stop here because you need only 3 numbers. Now pause the video and find 9P5. 9P5 starts from 9 and goes on until you have 5 numbers in the multiplication. So starting from 9, reducing by 1 each time, 9 times 8 times 7 times 6 times 5, you stop there because there are already 5 numbers starting from 9. Now looking into combinations, 8C3 is 3 combination 8 or 3 choose 8, which means this is 8 times 7 times 6 divided by 3 times 2 times 1, which is nothing but 8P3 divided by 3 factorial. So this is combination. This is how you find 8C3, 8P3 divided by 3 factorial. So pause the video and find 9C5. So starting from 9, 5 numbers and denominator will be 5 factorial. Therefore 9P5 over 5 factorial is 9C5. You can use your calculator and find the actual number for these things. Let's proceed further and see what is NP2. NP2. So you should start from n, reduce by 1 number until you have 2 numbers, which means n and n minus 1 should be multiplied. So NP2 is n times n minus 1. If it is 8P2, 8 times 7. If it is 10P2, 10 times 9. If it is, so for example, 100P2, 100 times 99. So 2 numbers starting from n. Whereas NC2 will be n times n minus 1 divided by 2 factorial. So 10 times 9 over 2 factorial will be 10C2, for example. So NPR in general will have n times n minus 1 times n minus 2 all the way up to n minus r minus 1 because you need to have r numbers starting from n, which is n minus 0. Therefore NPR is n multiplied by n minus 1 multiplied by n minus 2 and so on until you get n minus of r minus 1. So you can see that this is nothing but n factorial. From n factorial, if you take away n minus r factorial, then you are getting NPR. So n factorial over n minus r factorial is actually the formula for finding NPR. Whereas for NCR, we already know that it is NPR over r factorial. That should be NCR, not NC2. NCR is equal to NPR over r factorial. Using the formula we just saw for NPR, this will be n factorial over r factorial times n minus r factorial because n factorial over n minus r factorial is NPR. Therefore, the formula for NCR is n factorial over r factorial times n minus r factorial. So remember these two formulas to find permutations and combinations. So let's see what types of questions will be under permutations and what types of questions will be under combinations. For permutations, one of the questions could be forming n-digit numbers using a given set of numbers. Say for example, you have 1, 2, 3, 4, 5, 6, 7. You have 7 numbers. Out of these 7 numbers, you have to form different types of 5-digit numbers. So how many 5-digit numbers can be formed using the 7 given numbers 1 to 7? So this is one type of question that you can get for permutation. Once you see the forming of n-digit numbers in your question, it comes under permutations. Next is arranging certain number of books on a shelf. Say for example, you have 3 mathematics books and 5 science books and 6 English books. In how many ways you can arrange them on a shelf? This is a type of question for permutation. Seating certain number of people on a given row of chairs, it's same thing like arranging a number of books on the shelf. So you need to arrange certain number of people in the certain number of chairs. So this comes under permutation. Combinations always comes under forming a committee, forming the groups, creating groups from the given set of objects, forming a committee from a given set of people, and so on. So these type of questions come under combinations. So usually selecting people to form a committee, selecting people to form the group are under combinations. Let's see some examples for permutations first and then go to combinations. Some examples for permutations. Example number 1. How many 4-digit numbers can be formed using the numbers 2, 3, 4, 5, 7 and 8. So how many numbers are there? There are 6 numbers. Out of these 6 numbers, you have to form 4-digit numbers. So the solution would be, you have to think about it. This is forming numbers. Therefore, this is a permutation. So how many numbers are given? There are 6 numbers given. You have to take out 4 numbers each time and you have to rearrange them to form different 4-digit numbers. Therefore, this is a 4 permutation of 6 objects. Therefore, this is 6p4, which is 6 times 5 times 4 times 3. Using your calculator, or if you can multiply directly, the answer is 300. So there are 360 4-digit numbers from the given numbers 2, 3, 4, 5, 7 and 8. So let's proceed further. The moment you see forming 4-digit numbers, you should understand that this is a permutation question. So in the next question, we are going to see the same 4-digit number question, but we are going to be having some restrictions. Instead of giving certain numbers 2, 3, 4, 5, etc., we are given all the numbers from 0 to 9. So how many 4-digit numbers can be formed using these numbers? The first number cannot be 0. If the first place, that is the thousands place, is 0, it becomes a 3-digit number. Therefore, the thousands place cannot be 0. And whereas the other places can be 0. In all these examples, we are assuming that repetition is not allowed. So we have 4 digits like this. The first digit cannot have 0. Therefore, the options for this is the numbers 1 to 9. Therefore, there are 9 ways of filling this place. The thousands place, the first place, we have 9 numbers to be filled into this place 1 to 9. Once we fill this place, say for example, we fill it with number 3, the next position can be filled with any number from 0 to 9 except the number that we have used before. Therefore, 0 to 9 there are 10 numbers and we have already used one number for the first place. Therefore, there are only 9 ways to fill this place. Whereas the next 2 places we have 8 ways and 7 ways respectively, because we are already taking one number each for the first 2 places and one number each for the first 3 places. So out of 10 numbers, 2 are already being used, therefore 8 ways for the 3rd place, and 3 were already used, therefore 7 numbers for the 4th place. So it is 9 times 8 times 7. This is the total number of 4-digit numbers that can be formed using 0 to 9. If you use your calculator, you can find that this is 4536. So many 4-digit numbers are there using the numbers 0 to 9, and you cannot have 0 in the first place because that makes it into a 3-digit number. So whenever you have 0 in these type of questions, be careful, and you have to split the question in this way, and you have to find the number of ways for the first place and then the number of ways for the 2nd, 3rd and 4th, etc. Next type of question is how many 4-digit even numbers. I'm still making it more conditional. Even numbers can be formed using the same 0 to 9 digits. So we know that the first digit cannot be 0, and there are 10 numbers totally. 0 to 9 there are 10, and we need to use 4 numbers out of it. The first number again cannot be 0, but there is another restriction here. The last number, which is the ones place, can have only 0 or 2 or 4 or 6 or 8 because we need even numbers. Therefore, the ones digit can only be an even number here. So we cannot have the remaining numbers 1, 3, 5, 7, 9 in this particular position. So if you have 4 digits, the first digit can only have the numbers 1 to 9, whereas the last digit can only have 0, 2, 4, 6 or 8. In this, again, you have to split it into 2 cases. One case with 0 as the last number, the other case as either of 2 or 4 or 6 or 8. When you split it like this, you will understand why we are splitting this, because the first digit cannot be 0, right? The first digit can be only 1 to 9, and we have already chosen 0 for the last digit. Therefore, the second digit also can be only up to 1 to 9. We have already used 1 digit in the first place, so which makes it 8 numbers possibility for the second place, 9 number possibility for the first place, 7 for the third place, whereas 1 for the last place because we have already chosen and fixed 0 for the last place. So the permutation for this is 9 times 8 times 7 for this type of numbers where you have 0 in the end. In the next case, when you have 2 or 4 or 6 or 8, you have 4 options in the last place. In the first place, we have the same option 1 to 9, but we have already used one of these numbers 2 or 4 or 6 or 8, which is between 1 and 9, and therefore we have only 9 options in the first place. Sorry, we have only 8 options in the first place. And for the second place, we have 0 to 9. We can use 0 in these 2 places again. We have 0 to 9 possibilities, but we have already used 2 numbers in either ends of the 4 digits. Therefore, we have only 8 numbers left over. And for the third place, we have only 7 numbers left over, whereas for the last position, we have 4 options, 2 or 4 or 6 or 8. Therefore, 4 for the last position. Therefore, the total number of permutation here is 8 times 8 times 7 times 4. And these are 2 options which are to be added together because these are 2 different options we have. So when you add these 2 numbers together, we will have the final answer as 2296 4-digit even numbers using the numbers 0 to 9. So be careful about the conditions given in the question. The first question was without any restrictions and we didn't have 0 in the given set of numbers. The second question had 0 in the given set of numbers, but there was no restrictions as even or odd. But in this case, you had numbers 0 to 9 given to you, but we need only even numbers. Therefore, the conditions are more in these type of questions. You could also have how many 4-digit odd numbers. You can pause the video here and you can try to find how many 4-digit odd numbers are formed between 0 to 9. So let's proceed further. Another example. How many ways can a set of 7 books be arranged on a shelf if there are no restrictions? And then for question B, there are some restrictions, and question C, there are some restrictions. For question B, we have to put A and B together. For question C, we should see that the books A and B are never together. So let's first see question A. No restriction. So 7 books to be arranged on a shelf. So we have 7 books, 7 places. Therefore, this is 7p7, which can also be written as 7 factorial ways. So there are 7 factorial ways in arranging 7 books on the shelf without any restriction. Let's go further. We need A and B always to be together. So there are 7 books. Now we need A and B to be together. So let's put them both in a box and make this as one book. So there are now 6 books. We need to arrange these 6 books on the shelf, which is 6 factorial ways. Whereas this AB can either be AB or BA. So there are 2 factorial ways in arranging that one particular box in which you have A and B. Therefore, the box has 2 factorial ways inside that. Therefore, the total number of permutations is 6 factorial times 2 factorial. Number of arrangements are possible for question number B, where A and B are always together. Question number C says this A and B should never be together, which means this is nothing but the total number of arrangements minus the arrangements that has A and B together. So if you subtract the arrangements where A and B were always together from the total arrangements, you will get A and B never together. So it's the answer of A minus answer of B, 7 factorial minus 6 factorial times 2 factorial. You can use your calculator and get the value for this. Let's proceed further for examples with combination. The first example is how many different teams of 5 members can be formed from a group of 9 people without restrictions, and there is this captain who is supposed to be in the team as well. So the first question A has no restriction. Therefore, you have 9 people and you have to select 5 members out of the 9 people. Therefore, this is a combination question. So this is 9C5. And 9C5 is 9 times 8 times 7 times 6 times 5 divided by 5 factorial. You can simplify this using your calculator and get the number as 126. Whereas the second question has the captain in that. So we have out of 9 people, there is a captain. And out of 5 members in the team, there is this captain to be placed. Therefore, the total number of people becomes 8. And the number of members in the team becomes 4 because 1 member is already fixed for captain. So you have 8 members out of which you have to choose 4 members. Therefore, the choice is 8C4 and the answer is 70 if you use your formula for this. Next question is, how many different committees of 5 members, same thing, 5-member groups can be formed from a group of 5 men and 7 women. They are not all together. We have different genders here, 5 men and 7 women, and we have some restrictions, and number A is without restrictions. Well, let's first see what is the answer for the question without restriction. 5 men and 7 women. Without any restrictions, you have to choose 5 members out of this, which is simply 5 out of 12 members. So there are 12 members and you have to choose 5 members, which is 12C5. The answer is 792. The second question is, all members are women. So out of 7 women, you have to choose 5 members, which is 7C5, which is 21. So there are 21 committees with all women. So we don't need the men part of the given group. So there you only need to choose 5 members out of the 7 women. Therefore, 7C5 ways to choose this particular type of committee. The next is C. There must be 2 men and 3 women. So 2 men can be chosen out of 5 men and 3 women can be chosen out of 7 women, which is 5C2 times 7C3, which is 350. The question D is, there must be at least 3 men. So you can have 3 men or 4 men or 5 men. When you have 3 men, you have the rest 2 of the committee to be women. When you have 4 men, the rest of the committee will be woman, 1 woman. And when you have 5 men, it's all women. It's all men committee, therefore 0 women. So if you find the combinations for 3 men, 2 women, it is 5C3 times 7C2. For the combination of 4 men, 1 woman, it is 5C4 times 7C1. For the combination of 5 men and 0 woman, it is 5C5 times 7C0. If you use your calculator for all these values, you will get 246 as your number of committees that can be formed where you have at least 3 men in it. Question number E. There should be at least 1 of each sex, which means there is 1 man and 1 woman at least. But this is an opposite of having all men and all women group. Therefore, it is total minus all men minus all women. So which is 12C5 minus 5C5 plus 7C5 in brackets. The total will be 770 such committees can be formed. I hope you understood these concepts clearly now and you are ready for the exams. This is a quick review for permutation and combinations. You will have more reviews like this on other topics. So subscribe to this channel so that you will get updates as and when I upload new videos. Thanks for watching. Meet you in Ganatika.com. Bye bye.